Hey, what's up? So in this tutorial, we're gonna be making the stylized fireball effect from scratch, from the meshes and the material system to Niagara. So let's start. So for the mesh, we're gonna be using Blender as it's free and easy to use. We're gonna be using the general preset. Press A on your keyboard to select everything and delete. Then add a cylinder using Shift A. Here, expand this add cylinder drop down and change the cap fill type to nothing. Press Tab on your keyboard to go into the edit mode. Then press R and Y to rotate the cylinder on the Y axis. Then click Y here to view the y-axis perspective. Then press G and X to move the cylinder on the right side of the origin. Hold Alt and click here. Hit F. This will fill these vertices. Then press Ctrl R on your keyboard to add another layer of vertices. Select these vertices again and scale it like that. You can use S to scale them. Add another layer of vertices. Scale them here and make some adjustments. Press tab again and right click on it to shade smooth. Now let's go to file and save. Let's name it Stylized Fireball Mesh. Hit enter. So now let's export it. If we find any issues later on in Unreal Engine, we can just come back to Blender and make some adjustments. Go to file again, export as an FBX, select selected objects, go to geometry and smoothing to face and uncheck animation. Go to meshes, tutorial as this is a tutorial and export FBX. Save this and let's go back to Unreal Engine. Now let's make ourselves a new folder, Stylized Fireball, and bring our mesh right in here. Hit import. Now this is what we have. Now, as we see that the UVs are a bit weird. So for that, let's go back to Blender and uh, let's bring up the UV editing panel. Now, as we can see that the front of the fireball mesh is on the top and the back is on the bottom, just press R and type 180 on your keyboard. Now, as we can see that the bottom is on the top and front is on the bottom. Let's make some adjustments like this. Now let's go back to the layout panel, go to file, export, FBX. You don't need to change the name. Back to Unreal Engine and right click and select re-import. Now we can see that the UVs are much better. Go to file and save all. Rename our mesh to SM for setting mesh. That makes our mesh done. Now for the material, right click and select material. Name this M Fireball. Here, let's change the shading model to unlit and change the blending model to masked. Right click and bring out the particle color node and plug this to emissive color. Next up, we need a noise. So let's get ourselves a noise. textures, Vornai, and let's copy this to our folder. I know I said scratch, but if I started to make noise from scratch in Unreal Engine, it would be a really long video. So to make things easier for you guys, I'll be giving the link to this noise down in the description, so you guys can have similar results. Plug the R channel to the custom mask to see what happens. You don't need the RGB for this one. Let's add a power node for contrast and decrease it to 0.5. Plug this to custom mask, and right away we can see that the texture mask is much more visible. File, save all. Next up, let's bring a texture coordinate node, multiply it. We would be adding some parameters into the material system so we can later on modify them in the Niagara particle system. First two will be tiling, so tile X and tile Y. Make float 2 and plug this into the B socket or multiplier. Make another float 2, and for this we just need speed Y. So let's plug the Y into the Y socket and a value of 0 in the X socket. Organize the graph, plug this into speed, multiply it into panner, and panner into the UV socket of the texture. Now we can see that the texture starts moving upwards. For now, let's change the speed value to 0. To preview this material on our mesh, we can just select it and select this icon. Let's give a value of 0.5 in the speed. This is what we want. Nice. Now we will be adding some more nodes. So let's select these nodes and move them a bit aside. Back. Now, if we preview this material in our mesh, we can see that the start of the mesh is not being filled. So a material like this is not very ideal for the fireball effect. So in order to do that, we need the material to be filled on the start, and as the texture goes on the back of the material, mesh, then it starts eroding. So we can do just that. For that, let's add a component mask node, duplicate our texture coordinate, preview this mask, and uncheck the R channel. Add another add node. We can use add node to offset the mask. Now, if we preview the add node, giving it a value of minus 0.2, we can see that the mask is offsetted a bit downwards. The higher the value, the higher the offset of the mask. And the positive or negative value indicates the direction of the offset. So on the other hand, if we give it a value of 0.2, we can see that the mask is offsetted upwards. Move these nodes here and add another add node so we can add this noise to our mask. Now we can see that the mask and the noise are combined. Now, if we plug this into the custom mask, we can see right away that we have exactly what we want. Now, one more thing we can do here is add a multiply node to control the strength of how much the noise affects the mask. You can just hold M, hit the left mouse button on your graph, plug this noise to the A socket of multiply, and plug this into the add node. Now, more the multiplied value, the more it'll affect the mask, and the lesser the value, the lesser it'll affect the mask. We can make another parameter for it, name it fill strength, and plug this into the multiply socket. Organize the graph. You can also make another parameter for fill offset. So let's just duplicate it and change the parameter index to 1. Reset all the values. Just name it fill offset. Give it the desired value. And plug this into the add socket. The tile X a 0.7 value, so it is a bit stretched. That would make Fireball look more appealing. And give minus 0.4 in the fill offset. Maybe 0.6 in the tile Y. Preview it on our mesh. And this is what we have. Now the material part is basically done. If we have any changes in mind, we can just hop back into it. Now let's go to our content drawer and add a Niagara system. We'll be using the simple sprite burst preset for this one. Name it Stylized Fireball. Stylized Fireball here as well. We don't need the sprite render for this one, so let's delete it and add our mesh render and add our mesh in here. Material and add the material as well. Now go to initialize particle and change the color to a orangish color. Save all. Now let's preview it in our level. We can see that the fireball is not moving with our cursor. To change that, we just need to go to the properties of our emitter and check the local space. Works perfectly. Now we can see that the color of the fireball in our level doesn't quite match the one in the viewport in the Niagara system. That is because I'm using a post-processing unit with a custom exposure settings. So if you're as well, just go window here and select preview scene settings. Now go to this panel and search for exposure. Check these two options and change the mirroring mode to manual and exposure to the value similar to your post-processing unit. Go back to initialize particle and make the color more orangish. Let's change the exposure to maybe 11 or 10.5, maybe 10.2. Perfect. This seems to have a better match. Now let's rename this one to red and duplicate this and rename this one to black. We'll be using this one to mimic a outline effect. Now, if we go to initialize particle and change the mesh scale mode to uniform and increase the size, we can see right away that this is not what we want. We need the red mesh to be sorted above the black one, so it mimics a outline effect. In order to do that, we have two routes we can take. One is by changing the blending mode of our material to translucent and using the translucent sorting. And the other one is still using the masked blend mode and use the camera offset node. I'll be showing you the both methods So let's go back to our material. First of all, we'll be seeing the translucent sorting method. Change the blend mode to translucent and plug this value to the opacity socket. Now, right away, we can see that this is not what we want. This seems to have a different art style than a stylized look. So in order to have the same art style, we need to either use a smooth step node or a step node. Right click and add a step node. Plug this into the value socket, change the max value to 0, and plug this into the opacity socket. Now we can see that we have the same art style as before. And also use the step node. You can see that this has the exact same result as smooth step. Let's just use the step node for this tutorial. Apply everything and save. Change the offset to a value of minus 0.7 or maybe 0.6. Apply again. Now, if we go back to the Niagara system, we can see that the red is already sorted above the black one. So if we give it a fixed value of 1, we can ensure that the red mesh is always sorted above the black one. Now let's go to initialize particle of the red mesh and give it a particle offset. Increase the black mesh scale and increase a bit of offset. Now we can see that we have the outline effect in our level. This is exactly what we want. We can add another layer, name it core, go to initialize particle and give it a yellowish color. Give it a sorting number of 2. Now we can see that this is sorted above the red mesh. Now change the scale mode to uniform and decrease its size a bit. Tweak the offset a bit. Now, if we notice, we can see that all of the 3 layers are very similar to each other. So for that, we can add a dynamic parameter to give different variations to all of the emitters. Give them the same values as the material. Let's check. So this one, let's add 1 in here. Perfect. Change the offset to minus 0.6. Nice. Now let's just duplicate the same module in the other emitters so we don't have to do it all over again. Now if we increase the fill strength in the core and decrease the fill offset, we can see that we have this type of effect. Tweak the sizing a bit, make it a little bit lighter, and this is what we have. Okay, now for the second method, let's go back to our material. Let's just duplicate this and our Niagara system. Go to our duplicated fireball material and change the blend mode back to mask. Increase the mask offset and let's add the new duplicated material into the duplicated Niagara system. Now you can see that we have the exact same problem as before. Let's increase the fill offset. Give maybe a blur value into the core. Still we have the same issue. So in order to fix this, we can add a camera offset node. Let's change this parameter to camera offset. Right click and search for camera offset. Plug this value into the offset amount. Change it to a default value of 0 and plug this into the world position offset. Perfect. Now, still nothing happens. Save everything up. And we can see that we have a new value called camera offset. Now, as soon as I give this a negative value, we can see that the black mesh is pushed behind the red one, maybe -85, and give maybe 55 value to the core. Now we can see that we have similar effect. The advantage you have on this method is that this is much lighter than the translucent sorting method, as this one doesn't has any grayscale. It just uses the black and white values. But the downside of this method is that the sorting is not perfect. This is just mimicking the sorting effect. If we look at from behind, we can see that it has a weird sorting. Now, if we go back to our translucent sorting method, we can see that it doesn't have that issue. So we'll be using this one for this tutorial. Now, one downside of this method is that it is much more hardware expensive than the camera offset method using the masked blend mode. That is because it does use grayscale and it's just mimicking the look of the mask blend mode. At its core, it is still translucent. So it all comes down to what are you willing to compromise? Are you willing to compromise the aesthetics for the lighter effect? Or are you willing to compromise the lighter effect for the aesthetics? Anyways, let's get back to the effect. Now, if we see the edges of this mesh, we can see that they're way too still for a fireball. So in order to fix that, let's go back to our material. Let's duplicate our noise, panner, and texture coordinate and add the vertex normal node, add a multiply node, and add another one. The reason there are two is because one will define the value at which it affects the vertices of the mesh, and the other is just to multiply the noise with the vertex normal node. Plug this into the world position offset. Now, one thing is that if you're using the camera offset method, you can just add the camera offset to these values and plug that into the world position offset. You will have the same result, but we're not going to use that as we're going for the translucent sorting method. Now, as we plug this into the world position offset, we can see that nothing really seems to change. So let's change the speed to 0.7 and a value of 15 in the multiply. Still nothing. But if we change this to a sphere, we can see that the mesh is distorting. Apply this to our level and go back to our Niagara system, and we can see that our mesh is being distorted. Maybe give it a value of 17 in the multiply node, go back, and this is what we have. One more thing we can do is add a scale mesh size module and add a user parameter called fireball scale. Add this into the scale mesh size and we get in the altimeters. Change the red emitter scale to uniform. Now, if we tweak the sizing, we can see that it affects the whole fireball effect. This makes things much easier to tweak. Let's give it a value of 1.1 in the x-axis to stretch it a bit. And back to our level. This is our effect. So that's it. See you in the next one.